hopefully you've had a chance to look at the final exam review questions that are inside my lab math. I have printed them for you, and that's what your handout consists of. Those review questions are part of your handout. Looks like this. And if you'll notice in the back, you have answers to them. So that's just the review from my lab math that's printed for you. I just know that it works better when I can go through and work some of the problems on each of them. I picked out some problems for us to hit for that, but the first part of what we're hitting today is really here. It's in Module 10, Homework 1, and I really overkilled this one. So I'm not going to work quite as many problems as I have here in the sheet for you. We're going to do a selection, okay? And once again, I apologize if this goes really fast. I'm just making sure the recording is working. I just pulled my mic off. Hang on a second. Because you can go back. Slow it down, stop me, whatever, work the problems, and then listen to the explanation. So if I am moving too quickly for you today, that's fine. Listen, write what you can, and go back through this and do this complete review, okay? What I'm going to do, like I said, is give you one of each problem type that's going to be on your test, and it does cover everything. Your final exam is comprehensive, and it counts a good bit in this class. In fact, I just want to see, 70 or above on that final exam. I can see what I can do about other grades. If you can hit a 70 on that one, I can help you. But I can't really do anything if you don't at least pass this final exam with a 70, okay? Because that's what you really need, is the information that's in there. You need the knowledge that you're going forward in with this, then it's all covered in this final exam, all right? So let's take a look first at some word problems, because I know how much you love those. But this is one of those things that in Module 10.1, this is one of those things that is, we're looking with the sets of two linear equations, okay? So what you're thinking about is you're thinking about two different variables, solving an equation with two different variables. And this is the reason we have two linear equations and we use substitution or elimination to solve and then plug it back in and solve for the other variable. And so what you have to do when you have a word problem like this one is you're looking for, okay, one of them is an x variable and one of them is a y variable, and I've got to have two equations, two different equations that involve the x and the y. And then I can use elimination to solve. So see what this says. It says a woman brought some large frames for $17 each and some small ones for $8 each at a sale. If she brought 22 frames for $239, how many of each type does she buy? Well, I've got large frames that I'm going to call my X frames, and I've got small frames. I'm going to call those my Y frames. And you always have to identify that, okay? What's my X and what's my Y in this thing? All right, so it doesn't matter which one you set up. It really doesn't. But I'm going to say, so I know money. I know 22 of all of X and Y, was the total that she bought. In other words, the number of X frames plus the number of Y frames is equal to 22, isn't it? That's an equation. I know that. I mean, that from that thing. What else do I know from this thing? Well, I know the money, is equal to $239. What is equal? Well, the number of X frames times 17 would be the money I spent on those. And that would be added to the number of Y frames times, well, those were $8 each. I've now got two equations that I can use elimination or substitution to solve for. Now, when you just have X plus Y in one of your equations, it's easy to solve for one of those variables. I'm going to solve for X, and if I did that, it would be X is equal to 22 minus Y, right? I'm doing some shortcutting here, but I expect you're probably able to follow me by now, right? So I just subtracted Y from both sides. So now I know that. And now I can take X and I can plug in over here. Now I'm going to rewrite this thing because it's really 17X plus 8Y is equal to 239 is more how I'm used to seeing it. But I'm going to plug in for X into this equation, the other equation. I'm going to say 17 times, well, X is 22 minus Y, plus 8Y, right, is equal to 239. And then I've got one unknown I solve. I distribute multiplication. I say 7 times 22. Well, let me just tell you, that's 374. 7 times negative Y, that's negative 17Y. plus 8y. And then I'm going to get my y's together, right? Simplify over here. I've got a negative 17, a positive 8. That's 374, and it's going to be minus, and that's a negative 9, is equal to my 239. And then I'll subtract 374 from both sides, right? This is minus 374 over here, and then I go minus 374 over here. I end up with a negative 9y is equal to a negative, and when you say 374 minus 239, the bigger number is negative, so I know I'm going to have a negative answer. I'm going to end up with that being a negative 135. Divide both sides by a negative 9, and here I'll come up here. Y is now equal to, and it came out to be positive because negative divided by negative, and y is equal to 15. How many frames? Y for small frames? Well, she had 15 small frames. Now, how do I find out how many big frames she had? Well, let's plug it into either equation, but this one's easy, isn't it? If y is 15, then x plus 15 is equal to 22. Well, all I have to do is subtract 15 from both sides, and I find out that x here is equal to 7. How many small frames? 15. How many big frames? 7. Two equations. This is the whole reason we've been working at solving these solving these equations, systems of equations is what I'm trying to say. When you have systems of linear equations, you have two of them that relate to the same problem. You can solve for two different variables by using elimination or substitution, and that is the reason we've been doing this, okay? Now, let's see what I've got here. Problem B says one number is 2 less than a second number. 6 times the first is 10 more than 4 times the second. Now, this one to me is not two equations. They're not talking about two separate things here. They're not talking about big frames and little frames or hot dogs and hamburgers. You know, they're talking about these numbers, and they've got the numbers in relation to each other. So what I have to do is say, well, which number do they tell me nothing about? Well, they said 1 is 2 less than the second number. They didn't tell me anything about the second number, did they? I'm going to make that second number, I'm going to make that x. And then that first number that they talked about is 2 less than x. Well, that's x minus 2, isn't it? Not 2 minus x, because that subtraction less than, if you see these words less than, you translate it backwards. You put the x first and the 2 second. Watch for less than, right? And then you're going to say 6 times the first number is 10 more than 4 times the second. Well, I can write that down. 6 times the first number. Well, 6 times the first number. 6 times x minus 2. Is equal, right? 10 more than 4 times the second. Well, 4 times the second would be 4x, wouldn't it? 10 more than that is going to be plus 10. Now, I could have written 10 plus 4x. Would it have mattered in solving that? Would it have mattered if I'd said 10 plus 4x or 4x plus 10? Somebody say no, please. No. Okay, thank you. So now let's distribute. 6x, right? Minus 12 is equal to 4x plus 10. Now let's get the x's together. I've got more over on this side, so I'm going to subtract 4x here. And I'll end up with 2x minus 12 is equal to 10. And then I'm going to add 12. However you do this, if you're combining these steps by now, that's fine. And the final step, you save division for last. So what's the first number? Well, the first number is 11 minus 2, or 9. The second number is 11. And plug it back into the thing and see if it works, but those are the two answers. Those are the numbers, aren't they? Now C, here's our hot dogs and hamburgers, okay? There's a concession stand. 3 hot dogs and 4 hamburgers cost $11.75 together, all together. 4 hot dogs and 3 hamburgers cost $11. Do you see, you begin to see where I've got 2 different equations using those variables, and I've got 2 different variables. I got hot dogs and hamburgers. So make one of those x and one of those Y. I forgot what I made. I made hot dogs X, so let's just go with that. And I made hamburgers my Y. And I know that, and that's the number of hot dogs, right? Number of hot dogs, number of hamburgers. So I'm going to say if I have 3 hot dogs or 3 X's and 4 Y's, it's going to cost that much money, right? I'm sorry, that's not the number of them, that's the cost of them this time. So I've got 3 times the X plus 4 of those Y hamburgers, and that's going to equal $11.75. First equation done. And then I've got 4 hot dogs and 3 hamburgers this time. Well, that's 4 X's and 3 Y's, right? This time I got 4 X's plus 3 Y's, and that equals $11. Don't forget the decimals because you'll mess up. I mean, you'll get into big trouble if you do on these when it's money that you're dealing with. Now, I've got to figure out a way to solve this thing, and we did one way last time. Let's do, I guess I'll do the same thing this time. I'm going to say I really want to get one of these. Now, I want to get one, I'm going to use elimination is what I'm going to use before I use substitution, so I'll use elimination this time. And I want to get one of these to be either, let's just do the Y's. I want to be opposites, right? I want to get them so that I can subtract them. I can add them together and they come out to be nothing. You could do it with the X variable or the Y variable. And when I worked this before, I said, okay, if I could get one of them to be 12Y and the other one to be negative 12Y, right? That'd work. So I'm going to work on it. I'm going to say if I multiply all of these times 3, that first equation would come out with 12Y. It would come out with 9X plus 12Y. And that would equal, just trust me on this because I already did the multiplication and we're in such a hurry here. Let me see where I put it. No, I can't find where I put it. Hang on a second. Is it 3525? Thank you. Okay, 3525, okay? And then I'm going to multiply this one times, well, a negative 4. I want it to be the opposite, so I'll say multiply times negative 4. Now I have to multiply every term times a negative 4, so this comes out to be a negative 16x. I did this just the opposite before, so we'll just see if I can. And that's going to be, whoops, and that's going to be minus 12y, and that's going to be minus 44, right? Dollars. All right, now I can add them together, and I will eliminate these 12 y's. What do I end up with? I end up with a negative 7x, and that negative 7x is equal to a negative 875. And then when I divide by a negative 7, I end up with x is equal to a positive $1.25. That is the cost of what? My hot dogs, right? There's one of my answers. So how do I find the price of the hamburgers? Well, plug it into either of these other equations. I'll choose the first one. I'll say 3 times 125, right, plus 4y is equal to 1175. And that comes out to be 375 plus 4y is equal to 1175. And okay, I'll have to subtract 375 from both sides. I'm almost to the point with you guys where I'm not writing this stuff down. 4y is equal to, what, $8? And then I divide both sides by 4. And I see that y is equal to $2. That's the cost of my hamburgers. That is the, one of them I did with substitution, one of them I did with elimination. It doesn't matter. You can solve them any way you want to, okay? It's not going to be picky about this. Okay? Maybe that'll help you get that page under your belt. The next one is a page full of word problems that we simply don't have time. I'm skipping. So let's go straight to page 3 here and take a look at some graphing. Now this is not going to be a big switch over what you've already done with graphing, all right? We're just going to add one little thing to it. Well, okay, we're going to add 2 little things to it, but it's not a real big deal, okay? So what we've got here, and it tells you, you know, we're graphing linear inequalities, and we're going to determine first if the line is a solid dash. We're going to graph this line. Is it a solid line or is it a dashed line? Simple, easy. If it has an equal, it's a solid line. If it doesn't have an equal, it's a dashed line. Everybody got that? I'm going to make a dash this line. In other words, it won't be equal to the line. Now, the other thing is you have to determine which side of that line are my answers on. Are they on, you know, the right side or the top side or the bottom side, depending, which side are they on? Well, the only way to find that out is to pick a point. You pick a point on one side of the line and you check it in the equation. If the equation turns out true, then that's the side that the graph is on. If the equation turns out false, then it's the other side. And what point do you choose? Guys, make your life easy. Choose 0, 0, okay? It will solve your math so much simpler. So just watch what I'm going to do here. It's really not hard. Let's graph this thing. If you can get it to y is equal to mx plus b, that's your easiest graphing method. So let's do this. Let's subtract 4x from both sides. And let's say that means y is greater than, writing it, y is equal to mx plus b, right? So what is the slope-intercept? Well, it's 0, 2. What is the slope? I'm sorry, y-intercept. What is the slope? Well, it's negative 4. Now, we always write slope when we're graphing. We write slope as a fraction. And then we say, okay, that's negative, so it means I'm going to go down, and that's positive, so I'll be going to the right. Use arrows to help yourself out, okay? Where do I start? At my y-intercept. Go to 0, 2. Well, that's 0, 2, isn't it? Right here. I got 0, 2. Where is my next point? Down 4 to the right 1. So I start at 0, 2, and I go 1, 2, 3, 4, and then I'm going to go to the right 1. Now, if I want my next point, where do I go? Well, down 4, 1, 2, 3, 4, to the right 1. Could I just keep doing this forever? Yep. I just keep graphing forever, right? Draw a line right through. Is it dashed or is it? It's a dashed line, so be careful. Draw a dashed line, right? Here it is. Dashes, because it doesn't have equal in my linear equation. Okay, I got the line. Now the question is, which side of that line are my answers on? Okay, I told you pick a point, and unless the line goes straight through 0, 0, you pick 0, 0. It doesn't go straight through 0, 0, so I'm going to choose 0, 0. And I'm going to say 4 times x of 0 plus a y of 0 is greater than 2. I just plugged 0, 0 back into my original equation. And then I solve. I say, well, that's 4 times 0. That's 0 plus 0. That's 0 is greater than 2. Is that a true statement? Not true. So my answers are not over on this side. My answers are over here. And that's the area I shade. It is a dashed line, so those points that are on that line will never be a part of the answer. But everything over there to the right will be. How do I know that? I checked the point on the other side and it didn't work. It made my equation false. Why did I check 0, 0? Because it's easy. Do easy math if you can, okay? All right, let's take a look at another one. I'm going to go to number 3, the next one we're going to hit. And I'm just doing this because I want a chance to hit one of every problem on your final. So I'm making it fast, like I said. Okay, here's an equation. Now, this particular equation, doesn't look like y is equal to mx plus b format to me. And you could choose to graph it by point plotting. But I always have trouble point plotting. You know why? I end up with fractions as my answers, don't you? I end up with a point that's like 25.7, and I can't plot that very easily. So I'm going to go y is equal to mx plus b. I'm going to say subtract 2x from both sides, and I'm going to say 5y is greater than, well, I need the x next, so it's a negative 2x minus 25. Now, I divide everything by 5. Well, there's 3 different terms, so I'm going to divide all 3 of them. And this comes out to be y is greater than, whoops, it's a fraction. We don't care if a slope is a fraction, do we? In fact, we're happy with that. What is my y-intercept? Well, it's always an x of 0, and whatever that b coordinate is, that's it. That's the y-intercept. And what is my slope? A negative 2 over 5. Now, keep the negative if you have one in the numerator and say, okay, that means I'm going to go down and to the right. And if you do keep the negative in the numerator, then you're always going to go to the right, okay, which makes it easier. Let's find our starting point. It's 0, negative 5. Here it is, right? And what do I do next? Well, I go down and to the right, 2, 3, 4, 5. There's my next point. Where would my next point be? Well, I go from there down to 1, 2, 3, 4, 5, almost off the chart, right? That looks like my line. Let me see what it looks like when I graph it. Is it solid or is it a dashed line? Well, can we just pretend for a second that I changed to this and made that equal? Can you do that? Okay, do that. Let's just make it equal. You know why? Because this one would be a solid line. Before we graphed a dashed line, let's make this one solid just for variety. Right, so here is my solid line this time because I fixed it and put an equal there. And now I have to say, do I go over here on the top of it or on the bottom of it? Well, look at that point 0, 0. It's easy to check it. I say 2 times 0 plus 5 times 0 is greater than or equal to a negative 25. Well, that's 0 plus 0, isn't it? 0 is greater than or equal to a negative 25. Now, at first glance, some of you are going to want to say false. But remember, that's a negative 25, right? 0 is bigger than a negative 25. So, yeah, this is true. So that point is a part of my answer. So my answer is shaded over there. Now, some of you are going to ask me, are we going to have to graph these things on the final exam? It's multiple choice final, so you will have 4 graphs to pick from. Okay? You'll have the graphs, you'll pick from them. It's what it is. But you do have to know which graph is the right one. Any questions? So far, are we okay? I mean, that's the 2 sections we haven't covered. And My Lab Math does a really good job of filling you in on anything that I rushed through today because we simply don't have time at the end of this class. And you should be okay with those word problems and studying it like I just showed you, okay? Now, let's see if I can get you to that review, which is final exam questions. And to save time, I've already written them down, but you have the pages that I've given you, okay? And I am telling you which problems I want you to concentrate on. Number 5, okay, we're going to start there. And it says basically solve the equation. If you have an equation that has fractions, you find the least common denominator, you multiply every term by that, and you clear the fractions, okay? So I've got a denominator of 10, 5, and 5. My LCD is what? Somebody tell me. 10. So I will say multiply this times 10, multiply this times 10, multiply this times 10. Cross reduce before I multiply. Well, that's 1 times 7x, isn't it? Plus, well, this one's going to divide by 5. So that's going to be 6 times 2, which is going to be 12. And this one's going to divide by 5, and it's going to be 3x times 2. That's going to be 6x is going to be that one, okay? All right, so what do I do next? Well, let's get the x's all on one side and the variables on the other. And you know what? You can do it all in one step. I'm going to move my x's over here to where I have a positive 7x. I have more x's on this side than that side. I mean, you don't have to do it that way. Okay, we'll do it the other way. Subtract 7x, right? That makes your life, some of you, easier. I've got a negative x. Don't leave it like that. You have to now say divide by what? Yeah, you got to you can't solve for a negative x. And there's my solution. X is equal to negative 12. Just remember clearing fractions. Now this second problem, which is number 9 on your list, on your page, you might want to flip over to that page. Number 9 is saying solve for b, right? We had to do this on the last test, so I'm going to go through it quickly. It's still an equation that has fractions. Least common denominator for this thing, well, there's only one denominator, so it's 2. Now, I'm going to multiply this term. All of this is multiplied together, so it's one term. If I multiply it times 2, it'll clear the fraction. Don't forget you have to multiply the other side times 2. So I've really got 2a is equal to, well, that gets rid of the fraction, and all I have left is 1 times b times h. Now I want to solve for b, so I will divide out the h. Whoops, that looks like a b. When I do that, I have my solution right there. b is equal to 2a over h. Got it? We did this on the last test, so I know you're really familiar with it right now. Now, 7 is a word problem that always throws people because it is where the original is unknown. So flip back to number 7 here with me real quick and look at it. It says there's a diamond ring that it sold for $28.48, and that included the tax. And then they told you the tax rate was 7.8%, and they want you to find the price of the ring before tax. Well, guys, listen to me. You cannot multiply that percentage times the price after tax because the tax is included in that. The only way to do this is with that formula I showed you. So remember the formula? It says take the original, add to it the original amount times the percent, right? Whatever the percent is. And then that's going to equal whatever your final cost or your final price or your final number is. Now fill in the blanks. I know the percentage, right? It's that percentage. It's I'll write it down here, 9.8%, right? I know the final price. The final price was $28.48. I don't know the original. It's there in 2 places. So I make that my X. That's easy now. It should be easy now. Let's write it down better. X plus X times what? Well, we never work in percentages. We change it to a decimal. Move it 2 places to the left, and I've got 0.078. And that is equal to my total of $28.48, right? So I got that, and I go, okay, I need to add my x's together. And this is where some people get confused. This is 0.078x, and how many x is this? Yeah, so how many is it? 1, thank you. I need the number, don't I? 1x. Because I can add 1 and 0.078. I get 1.078x is equal to 28.48. And then all I do, calculator in my hand, is divide by 1.078. And I find out that the original price, the unknown, the original price here is 2641.9. I'll round it to 2 decimal places because it is money. 0.93. Okay? All right, I know I'm flying, but I do know you have a recording. You can go back and get your notes filled in later, okay? Let's take a look at this number 11. It says decide whether these lines are parallel, perpendicular, or neither. They're already in y is equal to mx plus b format. So what they're asking me about is the slope, right? Well, the slope of this one, the first one, is a negative 11. The slope of this one is 7/2. Well, they're not parallel because they would have the same slope. They're not perpendicular. One of them is positive, the other one negative, but they would have to be opposite reciprocals of each other, and they're not that. So these things are neither, okay? They're not parallel, and they're not perpendicular. Find the slope and do your comparison from the slope. And to do that, sometimes you have to get it into y is equal to mxb format, but for this one we didn't, all right? All right, take a look at number 15 now. I will find it in just a minute. Okay, I want the domain and I want the range of this thing. Now remember what domain is x and range is y. You got it? Domain is x, range is y, okay? So if I look at how far x is, I'm going to be looking at left and right, right? How far does this thing go? Well, for some of us, it looks like it's going to stop out here. But guys, it's not. If it goes to infinity, it's going to keep on going and keep on going. And even if it's slanted just a little bit, it's never going to reach it. It's going to be pointed toward the very far reaches of the negative infinity. So this thing for x is going to stretch from negative infinity to positive infinity. That's my domain. I found one of those. I found one of those in an answer. Do you see it? Okay. Next, how about y? Well, the smallest it's going to get is 2, and it's going to go from 2 all the way up to infinity. So I got to find a 2 to infinity. Does it include the 2? Well, yeah, it looks like it does. 2 to infinity, right, is here it is. What's the difference in that one? Oh, Is it a function is the only other question, right? Well, is it a function? You would kind of, with this one, do the straight line test. Is there anywhere you can draw a straight line, up and down line on this thing and hit the line more than one time? Nope, so it is a function. All right, that's just a little refresher on maybe helping you get back to what you remember. Let's take a look at number 16 is next. I don't know what I'm doing with my notes. Hang on. Okay, for 16, what I've got is it says function of x. I say function of x is equal to 3x squared plus 5x, and it said it wants a function of 4. What do? You just plug in the 4 for x. And I did that. And then all I have to do is solve it, right? I would square it first, so that's going to be 3 times 16. You can multiply this if you want to. And that's going to be 48 plus 20, and that would be 68. So the function of 4, as far as this equation goes, is 68. And that should be fairly simple for you. The next one I hit was number 22. All right, for this one, what did it ask? It said graph the equation, right? And that's my linear equation. Fortunately, it's already in y is equal to mx plus b format, so it's easy to graph. Let's find the y-intercept, 0, -3. Let's also find the slope, 1, 2. That means I'm going to go up 1 to the right 2. Draw your little arrows beside your slope so that you don't get in the heat of the moment, right, confused. And then let's find our graph. Well, for this one, I've got the first point is 0, -3. First of all, though, let me point out something to you. In this linear equation, do you have a positive or negative slope? Okay, it's going to be an uphill slant. Look at your graphs. You only got 2 to choose from. Wait, these 2, right? These are my only 2 choices because I have a positive slope. Okay, I already did the 50-50 thing then. I eliminated the 2 that I know are false because the slope is positive 1/2. And then the other point, where is the y-intercept? 0, -3. Well, this one doesn't have 0, -3 on it, does it? This one has the potential of 0, -3, doesn't it? And that's how you find these really, I mean, it's so small I can't really count it. I'm not positive about it, but I'm thinking that's the point, isn't it? Because the y has to be negative for that particular y-intercept. You understand? Sometimes it's just, you didn't have to work any math on that one. You just had to know what a positive slope looked like and then be able to find the y-intercept, and you would have found the right graph. Let's see, what did I do next? 26, is that what I did next? Okay, 26. Find the equation of the line, write the equation in standard form. And listen, pay attention to the words, right? They don't want y is equal to mx plus b. They want something x plus y equals a number. That's standard form, isn't it? So what I've got is a slope of -7/3, and it passes through 0.30. All right, so what am I going to do? Well, I'm going to kind of plug it in here. Where did I put this one? 26. I'm going to use my y minus y1 is equal to m times x minus x1. And the point I'm using, this is going to be my x1 and this is going to be my y1, right? So now let's just plug it in. I know what m is. I'm going to say y minus 0 is equal to the slope of -7/3 times x minus 3. All right, now I just have to get it kind of figured out. Well, y minus 0 is just y. And this is a -7/3 x. And then when I multiply -7/3 times -3, I get a positive. The 3's will cross out. I mean, do it like this if you need to, right? And you're going to get a positive 7 over here. All right, well, that's not standard form, and I'm going to have a hard time figuring out the answer if I can't get it in a better standard form. But look, The answer was in whole numbers, wasn't it? Look back at your answer. The answer's got all whole numbers. Well, let's get rid of this fraction. Let's multiply everything by what? 3. All right, so times 3, times 3, times 3. This one turns out to be 3y. This one is negative, well, those eliminate, 7x. And this is plus 21. Well, now let's get the x's go to the other side, because that's what we need, right? So I'm going to add 7x. And I end up with, well, x term first. That's standard form. And this is equal to 21. And there I found one of my answers. Okay. Next on the list, let's look at an easy thing. Okay, I don't even really need to write this one down. This one on 29 is the one I'm going to next, everybody. I feel like I'm speaking at a marathon pace. Okay, so 29 is the one we're going to next, and 29 says find the equation of the line and write it in standard form. But look, what it tells me right off the bat is this: it's a horizontal line. Okay, a horizontal line is like this, right? What kind of slope does that have? It is. I know the slope is equal to 0. If the slope is equal to 0, that means the equation of my line, listen to me, is y equals something. If the slope is 0, the equation of my line is y is equal to something. If the slope had been undefined, or if it was a horizontal line, the equation of my line would be x equals something, okay? So here I've got a horizontal line. I need to find out the y, the point where y is. Well, look, there is a y coordinate, and all y coordinates in this particular line are the same. So what's the linear equation? Y is equal to -5. And that's standard form, because it's got the x's and the y's on one side. The x just happened to be multiplied times 0, which was the slope, so it disappeared, right? Okay? Okay, let's graph an inequality. We just did this, so I feel sort of silly doing this with you again, but let's look at one so you can see what it'll be like on the test. Okay, we're going to do number 33. And the linear inequality for this one says y is less than or equal to 4x plus a -2. Well, that's really y is less than or equal to 4x minus 2. Graphing it, I would say, what's my graph going to look like? Well, B, the y-intercept, is 0, -2. That's the first point. Slope is 4. Well, I'll put it over 1. It means I would go up 4 and to the right 1. So I'm going to find a graph. And what kind of slope does it have? Positive slope, right? It's a positive slope. It's going to be an uphill line. So look at your graph. Oh, the other thing. Is it dotted or dashed? I'm sorry. Is it dashed or solid? Solid line. So I know it's got an uphill slope. I know it's a solid line. Okay, where am I? Okay, so on this particular one, which two? I mean, I've already eliminated 2 of them, haven't I? It could be A or it could be C. I know I'm between those 2. And the other thing is, man, the graph is exactly the same. They've already graphed it. So what is the big issue here? Well, the big issue is which side. Let's check out this point right here, which is 0, 0, which is not, it doesn't go through 0, 0, fortunately. So let's try 0, 0 and see which side it is on. Where am I? So I would say 0 is less than or equal to 4 times 0 minus 2. Okay, so that's really 0 is less than or equal to a -2. Is 0 less than or equal to a -2? Nope. So 0, 0 is not on my graph. 0, 0 is not on my graph. Is this, is this one, right? Because the other one, 0, 0, is on my graph. You could pick a point further out if you wanted to. You could pick, for example, you could pick something like 1, 1 or 2, 2. You know, make your math easy if you want to be really clear. Just find out if it's on the graph. And then you know which side to shade. Okay. 38 is next. And this is another, where did I put it? This is another one that is going to be word problems, right? So this is going to be two equations that we have to set up and we have to solve for. So we have a bulk food, and they sell trail mix for $9 a pound and cashews for $14 a pound. And the manager is going to mix up a bunch of, well, 250 pounds of it, and he's going to sell it for $10 a pound. So how many pounds of each does he need to use? Okay, so he wants to sell it for $10 a pound, but what do we know? We also know that he has 250 pounds. Let's make the trail mix, I'm going to try and make the trail mix the same one I made it before, X. And let's make the cashews Y. Now that's the number of pounds of cashews, right? So we know how many pounds total? Well, we know the cashews plus the trail mix is going to be 250, don't we? And then what else do we know? Because we got two equations. We're going to have two equations if we're going to solve for two variables. We know that there's, the money. We know it's going to equal $10 per pound, right? So $10 per pound would be $10 times the number of pounds, the 250 over here. And we would have $9 times the trail mix plus $14 times the cashews. There's my two equations. That is the hardest part, is setting up the two equations, okay? How do you feel about that one? You want me to solve it? Yes or no? Yes? Okay, so let's solve it then. All right, so what I did was set up these two equations. I said trail mix plus cashews are going to be 250 pounds of it. And then I know the money is going to be 9 times the trail mix plus $14 times the pounds of cashews. And that's going to equal the 250 pounds times the $10. That's going to be the cost of it, total cost. So this one's money, this one's pounds, but both of the relationships are cashews and whatever. So what I've got to say is, what way do I want to get rid of this? I'm trying to remember what method I used before. So I think what I can do is, one of them's already, let's just solve it for x. X is equal to 250 minus y, right? And then I can take it and plug it in for this y down here, right? Take this and plug it in for x. So I will say 9 times 250 minus y plus 14y is equal to, well, that's 250 times 10, which is 2,500, isn't it? Okay, so 9 times 250, distribute this multiplication. I get 2,250 minus, distribute this, minus 9y plus 14y is equal to 2,500. And I combine these two, because they're both y's. I have 2,250. Well, that's 14 minus 9, so it's going to be positive 5. Is equal to 2,500. And then I'm going to subtract 2,250 because I want the y to be by itself. Right? So this goes away. I've got 5y. And what is it equal to? Well, that's going to be 250. Divide by 5. And y is equal to 50. Okay. What did it tell me? Well, that's the pounds in cashews, right? I got 50 pounds of cashews. That's what he needs to use. So how many pounds of the other does he need to use, of the trail mix? Well, let's just take it back and put it back into put it in either equation, but I'm going to take it to the easy equation. I'm going to say x plus 50 is equal to 250. And any of you can look at that and say, well, then x is equal to 200, right? So I'm going to have 200 pounds of trail mix, 50 pounds of cashews. Okay, number 44 is next on your list, and I'm only halfway. All right, this one's easy, though. Look at this problem. This one says 4 to the negative 1, x to the negative 4, y to the negative 3, and it's all multiplied over z to the negative 3, and the whole thing is being raised to an exponent, negative 2. Now listen, if you have an exponent raised to another exponent, you do that multiplication first. Exponent raised to an exponent is multiply the exponents, especially if you got negatives involved. So let's do this. Let's take care of this outside negative 2. We'll say this one is going to be multiplied times that exponent times this exponent times this exponent and times that exponent. What do I have? Well, I have 4 squared, negative 2 times 1. I have x to the negative 2 times negative 4 times negative 2, which is going to be positive 8, and then I have y to the negative 3 times negative 2, which is going to be 6. Now let's do it with the denominator. Z to the negative 3 times negative 2, well, that's going to be z to the 6. And look, no more negative exponents, right? So now you could start simplifying if any of these terms matched, but these are x's, these are y's, and these are z's. The only thing left to do is let's fix this one. Because 4 squared, no reason to leave it as an exponent, is there? We know 4 squared. I mean, it's not like it's, 3 to the power of 292. You would leave that. There's my answer, isn't it? Okay, problem. Next problem for you is 53. And we're to factoring. Oh, yay. All right, so they want us to factor this trinomial. It is a simple trinomial with no GCF. Guys, please don't forget to check for GCF, okay? Simple trinomial with no GCF. I'm going to set the signs for it. That negative tells me I need one of each sign. I will factor the x squared. And then if you don't see the factors, you come over here and you set up the diamond pattern. You say that's the C term, the B term, and put whatever this is, the square root of it. If it had a coefficient in front of it, we would put the coefficient up there. And say I need factors of negative 35. They're going to come out with being 2. One of them is going to be positive, and one of them is going to be negative, right? So they're going to subtract to give me 2. And I would go through it. If you don't see it, you start 1 times 35, 3 doesn't work, 2 doesn't work. You'd end up with 5 and 7. I need a positive 2, so I'll make the bigger one set positive, okay? And then I say, okay, that's negative 5. This is positive 7. FOIL to check, right? FOIL to check. Every time you do it, FOIL to check. And there's my factorization. Simple trinomial. We got to do factorization in a couple of other things because I think 64 is the next one on the list. Because they want us to use this to solve equations. So let's take a look at number 64. This time it says solve. So it doesn't just want you to factor. Then you have to set those factors equal to 0, right? But to do this, you got to have everything on one side and 0 on the other. So I got to subtract 15 from both sides so that I get my correct trinomial. I have x squared plus 2x minus 15, and that's going to equal 0. I have no GCF. I'm ready to factor it. I'll put the pairs together, put that equals 0 so I don't forget to solve. The negative tells me I need one of each sign. Factor that x squared. If I don't see what the factors are, I will set up the diamond. And I need factors of negative 15. They're going to subtract. Look, one's positive and one's negative to give me a positive 2. What are they? 5 and 3. Which one has to be the negative? The 3. So I'll go positive 5, negative 3, and that's my factors. Okay? Simple factoring, which most of you have under your belt by now, right? Good? Okay. So one of the biggest complaints when you hit college algebra is the college algebra teachers say they don't know how to factor. And you have to know how to factor when you hit that class. If you don't, you're not ready for it. All right? It gets harder. It's 3 times as hard as this class, just to make your holidays brighter. Okay, sorry, but that's true. Okay, so now let's look at these two. We want to simplify. This is 66. We want to reduce them. We cannot until we factor them. They are both simple trinomials. I'm going to come over here and I'm going to set them up. I'm going to say, okay, factor pairs. They both are positive. That second plus says points to the first one. Going to be positive, x and x. And I'll come over here and do this factoring. 45, 14, x in the numerator. And what factors of 45 are going to add together to give me 14? 5 and 9. If you see it, you don't have to write all this out, okay? Foil it to check it, but we're skipping that because of time today. The next one is going to be another. Same signs. Factor the x terms. Come over here. What is it this time? Well, this time it's 81 and 18. Now look, I would recognize this as a perfect square trinomial. The square root of this one will add together to give me that, won't it? So what's it going to factor to? 9 and 9. Well, now I have two x plus 9s that will reduce. And what is my answer? X plus 5 over x plus 9. Can't reduce those x's because they're not multiplied, they're added, right? Now, did I do 68? There was a problem. Let me just tell you right off the bat. Take 67 on this review and cross it out. 67 is a cubes problem, and we took that out of the curriculum for this course a while back, but evidently forgot to take it out of the review. And I just happened to hit on it, and it is a factor in cubes, which you have not learned. Okay, so take number 67 and cross that one out. When you're working the review, you don't work 67. Let's do 68 though. It's it's really division of fractions. So before you do anything, you fix it to multiplication of the reciprocal, okay? The first one stays the same. We change it to multiplication and we flip the second one. And now we're going to start factoring everything we know about factoring. Okay, coming down here. This one is going to have binomial times a binomial. That negative tells me use one of each sign. Factor the x squared. I want factors of 6 that will subtract to give me 5. That's one way to look at it. Shortcut without the diamond, okay? Factors of 6 I can subtract to give me 5. Well, it's going to be a positive 6 and a negative 1. How do I know that? The 6 has to be bigger. 6 minus 1 gives me 5. Use the diamond if you need to, but that's a pretty easy one. This one is going to say, okay, another plus and plus, right? Factors of 18 that will add together to give me 9. Now, I might not know those. I would go over here and say 18. Well, 1 and 18 won't work. 2 and 9 won't work, but 3 and 6 does it. And if you just start factoring, you will find them. Break it down. If you get nervous on the test, you break it down just like I did. Start with 1, 18 divided by 1, 18 divided by 2, 18 divided by 3. If that didn't work, I go 18 divided by 4, which won't, right? And you would end up checking everything. Times. Here's another binomial pair. Positives. Factor the x's. Factors of 12 that will add together to give me 7. Will somebody tell me what is that? 4 and 3. So I got that one. And now this one, what do you see down here when I say x squared minus 1? What is it? A difference of 2 squares. So, one of each sign, square root of the first term, square root of the second term. Now I'm ready to start crossing things out because this is multiplication. Everything's multiplied. So I see an x minus 1 here, and I see an x plus 3 here, and I got a couple of x plus 6s. And what's left in the numerator is x plus 4. What's left in the denominator is x plus 1. That's about as complicated a one as we got for this test, I think. Like I said, skip 67. You don't need it. Let's look at 70. Now 70 is, and sometimes when these problems are thrown to us and we've covered a lot of material, it's hard to remember which type of problem I'm working. This one doesn't have an equal sign, guys. Did you hear what I said? You can't multiply both sides times the same number and clear the fraction if you don't have an equal sign, right? Right? Everybody with me? So what can you do? Well, you have to find a common denominator, and then you have to get them to that common denominator, and then you can combine them or add or subtract. So I've got a 7x and I've got a 9x. My least common denominator for this thing is going to be, well, it's going to have an x in it. What do 7 and 9? What's the smallest number? Both of them will divide evenly into. Well, actually, 63 is pretty close to it. Anybody see anything smaller? So I want to get this one to be 63x, and I want to get this one to be 63x. How do I change a 7x to a 63x? Well, I multiply it times 9, right? When I multiply this times 9, it's 54. How do I get 9x to become 63x? Well, I have to multiply it times 7. So I have to multiply the numerator times 7, right? And it becomes 14. And now I can say this is the same as everything over 63x, 54 minus 14 is equal to 40, right? Well, no. Is that right? Over 63x. And I would try to reduce it. They don't divide by 2. They don't both divide by 3. They don't both divide by 5, right? I mean, it's pretty much done. You'll be able to tell because you have a multiple choice test where there will be some answers there. Okay, take a look at this one. Now this one, there's 2 ways to solve it, but there's one way that I think this class agreed was the easiest, so I'm going to go there. I'm going to say this is a fraction divided by a fraction. In other words, this could be written as x plus 1 over 4 divided by 3x minus 1 over 20, which I would change to multiplication by the reciprocal. Now, can do some reducing, can't I? I can say I'm sorry, I messed something up and I'm trying to figure out where it is. No, I guess I didn't. Sorry. 5, right? So what have I got in the numerator? Well, I've got 5 times x plus 1. What do I have in the denominator? 3x minus 1. Is there anything else I can do? Well, if I multiplied that 5 out, it would give me 5x plus 5. That won't reduce. It's not the same terms, and that's where I leave it. That's it. All I can do. All I can do with it is all I can do. All right, let's take a look at 74. This one, they want us to use synthetic division. Yay, right? Okay, so let's see if we can remember synthetic division. First of all, this is a trinomial divided by x plus 5. Well, what are you going to divide it by? You're going to do the opposite of that plus 5, which is going to be a negative 5. And then I'm going to put inside my brackets, I'm going to say the coefficients of these 3 terms, right? Well, this is going to be a 1, this is going to be a 3, and this is going to be a negative 3. Now, the first one, I just bring it down. And then I say negative 5, I multiply. Negative 5 times 1, and I bring it up over here. That's a negative 5. When I combine these 2 terms, I end up with a negative 2. And then I multiply again. Negative 5 times negative 2 is a positive 10. When I combine those, I end up with a positive 7. Now, I'm at my answer. What is my answer? Well, it started with x squared. So down here, I'm going to say 1x. I could just write x, right? And then I go down. I say, okay, then instead of x term, it's just a plain number, minus 2. And this third one is the remainder. What's it over? Whatever you divided by, right? Up here, x plus 5. So it's really x minus 2 and a remainder of 7 over x plus 5. Okay, let's take a look at some fractional exponents, okay? Number 79. It has 8 x to the 15th, and it's raising it to the power of 1/3. Now remember, each of those things has to be raised to the power of 1/3. When you raise it to an exponent, remember, this is the root, and that's the exponent, right? It's going to be a radical. But let's take each one separately. Let's see, this is 8 to the 1/3. x to the, well, let's multiply those two, right? 15/3, right? Well, that's a whole number. That makes it easy. X just became x to the power 5, didn't it? Okay, so what is this? Well, it is the, what root? The root's in the denominator, so it's the cube root of 8. Does 8 have a cube root? 2. Remember, I said memorize some of them. You should memorize 1 cubed, 2 cubed, 3 cubed, 4 cubed, and 5 cubed. At least those 5. It's not hard. So this is 2. 2x to the power of 5. It simplified very easily. We didn't even have to leave a radical in that one. What about this next one? It's square roots. We're going to grab all the squares that we can out from under the parentheses, okay? Out from under the radical. Okay, so 63 is not a perfect square. Does it have any perfect squares in it? Well, 63 is 9 times 7. 9's a perfect square, isn't it? So 9 times 7. X squared is a perfect squared. I'll leave it. Y is not. So now I'm going to circle, I'm going to bring them out, right? Square root of 9 is going to be 3. The square root of x squared is going to be x. And I'll just go ahead and circle the ones that stay under the radical. What is this? I take the ones I brought out and multiply it times whatever's in front, which is just a 1. So I got 3x out here, don't I? What's left under the radical? I circled them, 7y. Look again. Can't get any square roots out of 7. I can't get any square roots out of y, right? All right, let's do a little bit more complicated with 84. It says negative 10 times the square root of 150 minus 4 times the square root of 216 minus 8 to the square root of 96. We need to get all the perfect squares out of those numbers, and they are not obvious. So I'm going to come over here and say, which perfect squares are in 150? Well, I know 25 is there. Let's check it. If I divide 150 by 25, how many do I have? 6, right? 6 quarters in $1.50, right? Well, there's no perfect squares in 6, so I found the only square. I'll just rewrite it as the square root of 25 times 6, and I know this one's going to come out 5, and I know this one's going to stay. Okay, I'll fix that later. This was minus 4 times what? I got to do the same thing for 216. Now, I understand you might not see it. You might not see perfect squares in it, but a good thing to try is 4. See if 4 works. Is 4, 216, can I divide it by 4? I get 54, right? Okay, so I got one perfect square. What about 54? Can I divide it by, what can I divide by? Okay, 2. I know it'll divide by 2, and then I get, what do I get, 27? Well, there's a perfect square in 27. So now here's the factors I've got. 4 times 2 times 3 times 9. And 2 of them are perfect squares. So I know that's not the prettiest job, but it'll work. I'll just write them down. 4 times 2 times 3 times 9. What am I going to bring out? Well, I'm going to bring out the square root of 4. And I'm going to bring out the square root of 9. I'm doing this just to show you that if you didn't see the perfect square of 6 inside 216, you would get to it anyway. I'm sorry, the perfect square of 36. You would get to it anyway, okay, if you did this. What's left? Circle it. 2 times 3, right? Okay, so we'll get that later. And then we have to do the same thing with this one. Okay, 96, still don't see any perfect squares. Okay, I don't know. I'm going to try 4. And when I do that, it goes 24, right? Well, okay, I see another 4, and this is 6, so that doesn't have a perfect square. So I can do the same thing. I say 4 times 6. What's the perfect square I didn't see inside 96? Well, it's 16. But you don't have to see it. You can bring it out in pieces, okay? I mean, do what you know how to do. That'll work. So what if I had to bring it out in 2 different pieces? Okay, so let's simplify this. I have to multiply whatever I bring out, radical times the coefficient. 5 times negative 10 is negative 50. What's left under the radical? Square root of 6. This is a negative 4 times 2 times 3, right? Negative 4 times 2 is negative 8. Negative 8 times 3 is negative 24. What's left under the radical? 2 times 3. Okay, square root of 6 again. This is negative 8 times 2 times 2. 16, well, it'd be negative 8 times 4, so it's going to be negative 32, right? What's left under the radical? Square root of 6. Now look, I've got all these square roots of 6's. All I have to do is say, well, that's like negative 50 minus 24 minus 32. I'll just add them all together and keep the sign, right? It's going to be a negative 106 times the square root of 6, isn't it? All right, let's take 88. It's 3x plus 4 plus 1 is equal to 4, and this is a square root of. Let's do this by getting the square root on one side, the numbers on the other. Subtract 1 from both sides of this thing. You will have the square root of 3x plus 4 is equal to a 3, right? Now, what do I do to get rid of the square root? I square it. Take this and square it. Take this and square it. So I end up with 3x plus 4 is equal to 9. And now I can solve. I just subtract 4 from both sides. I end up with 3x is equal to 5. And I will divide. X is equal to by 3, 5 divided by 3. And there's my fraction, but it's okay. All right, I've got a bunch to do, so I'm going to hurry, and you guys will have a video to listen to, okay? 89 is the word problem that's the Pythagorean theorem. What does 89 tell us to do? It says that there's a post that's been set up that is, I can't remember how high it is. Is it 10 feet? And it says that we want to anchor it, and so we've set up a stake so many feet out. Got to find it. Hang on. Okay, volleyball net. And one of the poles of it forms a right angle with the ground. This post is 6 feet high. Right angle to the ground, right? And how far out do we want to anchor it? 10 feet from the bottom. This is our imaginary thing. He wants to know how long is that. We'll make that C. We know the formula, a squared plus b squared equals c squared. So that's 6 squared plus 10 squared is equal to c squared. So we know this is 36 plus 100, c squared. And we got 136 is equal to c squared, right? And what do? Well, I say square root of both of those, don't I? And when I get that, it ends up being 11.7. And that's how you would do it. And you have your calculator, so I have no doubt you can do that. The next one. If I have two binomials that I want to FOIL and one of them has i's in them, just FOIL them. Remember that I squared is negative 1. That's all it's trying to make sure you know. 9 times 9 is 81. Outside would give me a negative 63i. Inside would give me a positive 63i. Well, that's convenient because those will cancel. This will be a negative 49. I squared, don't forget that. These middle terms go away. I have 81 minus, well, this is minus negative 49 times a negative 1, which is going to be plus 49, isn't it? And so all I have to do is add those together. I get 130. It said write it in, the number plus the number of i's. Well, it would be 0 i's, right? If you had to write that in that format. Now, what do you do when you have this particular one, which we've got this squared and it's equal to a perfect, well, we take the square roots, don't we? If I take the square root of this side, it's 2x minus 3, and then I'm going to take the square root of this one. Here's what you got to remember. If you take the square root of that side, it's got to be plus or minus. So now, what have I got? Well, that's going to be 2x minus 3 is equal to plus or minus 7. I've got two solutions. I will solve one of them with a positive 7, one of them with a negative 7. I'll say 2x plus minus 3 is equal to 7, and 2x minus 3 is equal to a negative 7. And then you solve. Add 3 to both sides, right? 2x is equal to 10. Divide by 2. X is equal to 5. I realize I'm going very fast. Let's do the same thing here. Add 3 to both sides. That's going to equal a negative 4. And that's going to equal, to when I divide by 2, a negative 2. Those are my 2 solutions for x. It's that way because I had to take the square root, and that gave me a positive and a negative solution, okay? Okay, going on. 98. I only have 3 more. I can make it, okay? 98 is 5x squared plus 22x is equal to negative 19. And I believe this one said solve also. And I believe this said solve using the Pythagorean theorem, okay? So Pythagorean theorem, remember the formula for it? If you have trouble with that, that's the first thing you write down when you get your test. Negative b plus or minus square root of 2a minus 4a, I can't remember. Negative, okay. I can't even remember. I can't say it right now because I'm in such a hurry. But you know the Pythagorean theorem formula, okay? So what we have to do is get this into the format we need, and what we have to do is add 19 to both sides so that it's equal to 0. A, B, C, right? So what I'm going to say is negative b plus or minus the square root of b squared, thank you, there it finally came to me, minus 4 times a times c, and all of this is over 2 times a. Okay? Just make sure you can plug in correctly to the Pythagorean theorem and do the math. You're going to square this first. Plus or minus the square root, and 22, let's see, all this comes out to be 484. This is negative 20 times 19 is what that is, which is a negative 380. And that's over 10, right? And this comes out to be a negative 22 plus or minus. And this is the square root of, what that come out to be, 26, I believe, over 10, right? Now, I'm looking, no, it wasn't 26, sorry. It was 104, okay? What am I looking for? I'm looking for perfect squares inside 104, and that's where a lot of you will go wrong. Perfect squares inside 104, well, I'm going to go 2, 52, and then I go 2 again and come to 26, and then I go 2 again and 13, simply because I don't see any, but there's a perfect square. 2 times 2 is 4, right? And this 26 has no perfect squares in it, right? 2 times 13. So what does this change to? It changes to 4 times 26. And I can bring out the perfect square of 2. I'm going to rewrite it so you can see what happened. 2 times what was left under the radical was that 26 divided by 10. Now look at this again. Each of these terms is even. I can divide them all by 2. Do you see it? You have to check and see if there are any perfect squares under that radical. So I divide negative 22 by 2. I divide 2 by 2, which goes away, right? So I've just got the square root of 26. And down here, there's my answer. Don't forget to bring out anything under the radical, okay? Let's see, 99. It's another Pythagorean theorem. You guys can bear with me just a second. I will finish this, okay? Can you stand it for just a couple more minutes? Yes? All right. Let's see if we can make this happen. So next I'm going to say negative b, which is going to be a 12